Today we're going to cover what are called flowcharts. Flowcharts are diagrams and they're used to represent algorithms, workflows, or processes. They utilize about 5 or 6 very simple, clear symbols to represent the different elements of an algorithm, a workflow, or a process. The first thing we're going to do is cover the fundamental parts, the symbols that are used, and then we'll show some example workflows or algorithms represented as a flowchart. Here's the first 3 shapes that are used in flowcharts. The first is a flattened circle, call it an oval. The name of that shape is start or end. It's used for either purpose. And the function of that is it shows the start and end of a process, an algorithm, a workflow, that sort of thing. The second shape is, well, technically it's called a parallelogram. If you go back to your geometry in school, both opposite lines are parallel to each other, parallelogram. The name of this shape is input, output, and its function is data entry or display. It's used for both. The third shape we'll look at is a rectangle, and the name of the shape is called process. It is used to symbolize a set of operations, and those operations, they change data. They can change its form, its value, its location. So that's the first 3 we'll cover, first 3 shapes: start, end, input, output, and process. Here's 2 more shapes that are used in flowcharts. The first one, a line or an arrow. The technical name of it is flow line. It's used to show the order of operation, what sequence you perform actions in. The next one is a diamond. The name of that symbol is decision, and it shows a conditional operation. This is where the path of execution is set. Now, a brief note before we jump to the final 2 symbols. What we just showed is pretty much every aspect of the fundamentals of a computer program. If you recall, in an earlier video we covered a start and end point in a computer program. We covered variables, and we covered conditional and branching statements, and we covered subprograms. Using these symbols, you can represent every single one of those elements. And because of that, they're quite useful for representing on paper the flow and operation of a computer program. Now let's look at 2 final symbols that are commonly used in flowcharts. Here's 2 final symbols that are quite useful in creating flowcharts, especially flowcharts that have many steps or cover a lot of space or are quite complex. These are connectors. The first one is a circle, and a letter would be inside it. And it wouldn't necessarily be A. If you had 5 of these, you'd have one with A, and one with B, and one with C, and one with D, and one with E that are used on the page. And what they are is, the name of it is an on-page connector. It replaces long flow lines where you have very complex routing flow line showing order of execution, or where they have a very complex diagram and it can be kind of confusing. You can actually use these in pairs to show where a flow line starts and where it's going to, rather than drawing the entire flow line. We're going to illustrate this. The second one is an off-page connector. You see the symbol looks sort of like a baseball diamond is about the only shape I can relate it to. Same thing, you put a letter inside it. Again, off-page connector, and it replaces long flow lines. However, this is for use in multi-page flowcharts, where the point you're starting from is on one page, and the point where it goes to, via a flow line, would be on another page. You can see that it would be quite impractical to actually draw a line that goes from one page and over onto another. So instead you would use an off-page connector. Good. Let's take a look at an example flowchart. Here's a flowchart that accomplishes the following purpose. Find and display the largest of 3 numbers entered by the user. Let's go through it step by step. The program or algorithm starts. Here's the symbol called start. It's the flattened oval. The next step is shown by this arrow. This is a flow line. It shows the order of execution of this process, this computer program. The next thing that's done is 3 variables get declared or created. Those are variables A, B, and C. Notice the rectangle is used. That is the symbol for process. Order of execution next goes to this step. This step, the parallelogram, is an input or output symbol. Here, what's meant to be done is we input A, B, and C. So the user has entered 3 numbers. The flow line or order of execution next goes to this step. This is a diamond. It's a decision. The computer program is going to make a decision at that point, and it's based on what this instruction is. Is A greater than B? There's only 2 possibilities. So, false and true. Excellent. Great. So if it's true, then the computer program next has another decision to make. Is A greater than C? If true, we now know that A is the largest of all the numbers. We've compared A to B, it was larger. We've compared A to C, it was larger. A is the largest of all three numbers. So we print, and here's the parallelogram again, for an output. Remember, it can be used for both input and for output. And we print A. So we've now found and displayed the largest of three numbers. You can follow the logic of all the different possibilities by going down the other branches. Remember, this represents those components that are common to any computer program, control and branching statements. So here's a control statement. We check, is A greater than B? Let's say it isn't. B is greater than A, so this ends up being false. We go down this flow line or path of execution, and we hit another decision to be made. Is B greater than C? And if it isn't, now we're going to print C. Because we've compared B to A, we compared B to C, we know at this point, with this logic, that C is the largest of the three numbers. So we're going to print that. And finally, this path of execution. We figured out that A is not in fact greater than B. Now we're comparing whether B is greater than C, and it is. We now know that B is the largest of the three numbers. We print B. Notice that we've accounted for all three possibilities of which one's the largest number. And when we're done, no matter what happens, whether it's A, B, or C that's the largest and gets printed, we finally terminate the program. We end the program by routing any of those with flow lines down to an end statement or an end symbol. So take a look at this in some detail. Make sure you actually follow the logic involved here and correlate the symbols that you see here to what you had before on the 6 or 7 fundamental symbols of any flowchart. Good. So now that you've done that, let's look at how we can use those final 2 symbols, the connectors that we talked about earlier. Notice right in here where we have both false on this comparison, this operation, this decision, and false on this comparison, operation, decision, and they both result in printing C. You could use an on-page connector like this. You come out of here as a flow line to an A in a circle. You come out of here with a flow line to an A with a circle. And then you have the A with a circle right here and a flow line continuing. Now obviously, there's very little space in between these, and as you can very clearly see the connection between, oh, I come out of here and make this decision, the result's false, so I have an A, I better find the other A that continues on with a flow line. And you search around and you find it. Again, quite simple. But for a very complex diagram where you had to go around several other symbols, this might be extremely valuable. So there you have an on-page connector. Now let's look at off-page connector. Here's an illustration of the use of off-page connectors. Let's say that it took all the space we had on the page to get from start all the way down to here where we've accounted for printing whatever the results are. But then we hit the bottom of the page, we don't have any more space. You could put an off-page connector at each of these points here for what to do after you've printed one of these variables. And then on a second page, have the corresponding pair labeled A as well, but we come out of it with a path of execution, a flow line, that points to that shape which represents ending the process. So there's an illustration of using an off-page connector as well. Now just a word from me about flowcharts. Use them liberally. They are an incredibly valuable tool for a software developer. They're actually valuable for anybody trying to organize anything. But in terms of software development, it's one of the most fundamental, basic tools that you have. If you cannot represent an algorithm or a computer program or a system using these symbols and this sort of logic, you can't build it. Or if you represent it this way, but you aren't accounting for certain possibilities, then your computer program is likely not to include those as well. Most successful software developers utilize flowcharts all the time. And in fact, Most commonly, they'll write the flowchart out for a computer program or a section of a program before they even write a line of computer code. I highly recommend this practice. And as you continue through the software developer training that you do, no matter whether it explicitly states to create a flowchart or not, you should be doing so. If you can represent it using a flowchart, then you'll be able to build it a lot more easily. In fact, what I find personally is if I have a well-documented flowchart, well put together, I actually just have it right next to me while I'm writing my code, and it makes the process of writing the code a lot easier. And you've got the certainty that while you're implementing what's here in your flowchart, that you're covering all of your bases. And you're not having to jump back and forth inside your code and make absolutely sure you covered everything. You've got it here. And if you've represented this logic in your computer program, then you'll have a well-organized, reliable, cover all of your bases computer program.